When a single API failure can bring your entire SaaS system to a halt, the issue usually isn't in the function call, it's in the architecture. I've seen teams delay feature launches because onboarding was blocked by billing. I've seen one failed analytics call disrupt entire user flows. And every time it came down to the same thing: too much coupling, not enough resilience. If you are building a SaaS platform with multiple modules, workflows, or tenants, this is where traditional architecture starts to fall apart. And in this video, I'll break down how event-driven architecture helps SaaS teams design systems that can scale without becoming fragile. We'll look at real examples, patterns, and trade-offs you will need to navigate. If you care about SaaS systems, AI integration, product strategy, and architecture that support scale, please subscribe now. I share these frameworks and breakdowns every week based on what I have seen across working with 200 plus SaaS builds. Now let's ground this in real systems. Slack, Netflix, Shopify, Uber, they all rely on event-driven systems. Slack uses events to stream messages across distributed shards. Netflix personalizes your homepage with real-time events from what you have just watched. Uber processes ride requests, driver updates, search pricing, all through asynchronous events. They are not doing this for fun. They are doing it because REST APIs with direct calls cannot support real-time logic across 100 plus microservices. Now, event-driven architecture gives them decoupling across services, independent deployment paths, and natural support for asynchronous flows. The moment your system needs speed, resilience, and scale at once, event-driven architecture stops being optional. Now let's understand the mental shift from functions to event. Most SaaS teams start with a synchronous thinking. A user sign up, backend processes it, downstream systems are updated with API calls. But with EDA, event-driven architecture, every major action emits an event. User signed up becomes a payload. That payload can be consumed by 3, 5, 10 services, each one reacting independently. You are not making a chain of calls. You are building a signal-based system where each service listens and acts. It's how platforms like Shopify decouple their checkout engine from analytics, billing, and fraud detection, all listening to the same event with zero tight coupling. That's the shift. Your services do not talk directly, they react to events, so they scale, fail, and recover independently. Now, before we go deeper, let's lay out the anatomy of proper EDA system. Every event-driven platform consists of 3 components. But here's the catch: you cannot just name them and move on. Each one needs to be designed with SaaS realities in mind. System number 1, event producers. These are the services that emits events. User service, payment processor, inventory manager, anything that changes state becomes a producer. But producer should do one thing only: emit. They do not care who is listening. Next system, event routers or brokers. This is your central nervous system. It routes, filters, buffers, and sometimes transforms events. Think Kafka, RabbitMQ, AWS EventBridge. The router needs to support high throughput delivery, tenant-aware filtering in multi-tenant setup, and durable persistence for replayable events. Third system, event consumers. These are the listeners, evil systems, analytics engine, third-party OFX processors. Consumers should be autonomous, so even if one fails, the others keep running. This triangle, from producer to broker to consumer, forms the asynchronous loop at the heart of every event-driven SaaS. Now here is where most SaaS teams hate friction. Multi-tenancy introduces a new layer of complexity. You are not just routing events, you are routing responsibility. Let's say tenant A triggers a payment success event. Now you must ensure tenant A's billing logic bundles it, not B's. The event metadata carries tenant ID, role context, and user scope. Any retries, failures, or analytics stay scoped to that tenant only. This is how Segment structures their multi-tenant event layer with scoped event buses, per tenant consumers, and clear boundaries in observability. Clark.io does something similar with auth events, ensuring no event crosses the wrong boundary. So if you skip this, one misrouted event could expose data or worse, cause billing confusion across tenants. Now choosing a broker, why it's a strategic decision? Time to talk routers. And this choice isn't about what is popular. It is what fits in your load and fault tolerance needs. Now here is how to think about it. Kafka. Kafka is very good for high throughput streams, replayable event logs, and data pipeline analytics. But it also comes with operational overheads, partitioning complexities, and heavier learning curve. RabbitMQ. We used RabbitMQ in multiple SaaS products. It is very good for transactional workflows, flexible routing, and guaranteed delivery. We are using RabbitMQ in our Allright app SaaS systems as well. Now it is very easier to set up but might struggle under massive concurrent loads. Now there are cloud native brokers like AWS EventBridge, Azure Event Hubs, or Google PubSub. They are very good for low operational teams, serverless compatible workflows, and native cloud scaling. You trade drip control for faster setup and auto scaling. If you're building an internal event bus for 50 plus services, Kafka's durability might be a lifesaver, but if you are emitting 5 to 10 critical events a day, EventBridge could save you weeks of your infrastructure maintenance. So you should choose based on throughput, durability, replay needs, and team expertise, not the brand name. Now what about event ordering, consistency, and rollbacks? Let's talk about the elephant in the room. What happens when events arrive out of order or fail mid-process? Here is where SaaS teams add real muscle. Number one, event sourcing. You do not store current state, you store every event that led to it. You can reveal state, time travel, or audit every change. Next is CQRS, Comment Query Responsibility Segregation. It separates the commands that mutate data from the queries that fetch it. It is great for performance and scaling. Next, Saga pattern. Instead of using a distributed logs, you orchestrate state transitioning across services with compensating actions. Now Netflix uses Sagas to coordinate billing, entitlement, and user state updates. For regulated SaaS platforms like health tech, fintech, compliance-based tools, these patterns are not nice to have. They are the minimum bar for auditability and trust. No matter how clean your architecture is, things will go wrong. And in distributed system, how you fail matters more than how you succeed. To build real resilience, you need to use dead letter queues. Catch unprocessable events and review them separately. Do not just discard them. You should add circuit breakers. If a consumer fails repeatedly, trip the breaker. Pause flow, alert the team, and recover gracefully. You should also implement retry with exponential backups. Never hammer a failing service. Retry intelligently. Airbnb and Shopify both build internal observability layers around their event buses because silent failures are worse than loud ones. And in event-driven architecture, your job isn't to avoid failure. It is to contain it, analyze it, and adapt. So how you should be starting to adapting EDA in a SaaS product? Most teams do not need a system-wide refactors on day one. Instead, you can do this. First, choose a low-risk event like user activity logging or sending emails post sign-up. Emit that event via a broker. Add metadata like tenant ID, timestamp, payload version. Now build 1 to 2 simple consumers. Start observing behavior. Next, you can add monitoring, retries, and schema versioning early. And then you expand gradually. Bring in billing, analytics, permissions as separate event consumers. This is how we re-architected parts of our Allright platform, workflow by workflow instead of blowing up the system. And it's how most modern SaaS platforms evolve towards event-driven thinking as a pattern of decoupling, not just a tool choice. So guys, the real benefit in event-driven architecture isn't performance charts. It's the freedom it gives your team. When service communicate via events, teams shift faster with less fear of breaking others. Features become plug and play. Monitoring becomes more precise. And failures become easier to isolate and resolve. So if you are building a SaaS platform meant to scale, EDA lets you scale not just traffic but decision making. And that's where most architecture wins are made, not in throughput, but in human speed. Now, if this gave you clarity, you will want to check out our next video on event schema governance, because even a good EDA system can unravel without clean versioning. And if you are building something ambitious, please hit subscribe. I'll walk you through the architectural playbooks most teams wish they had from the day one. Thank you so much for watching.